I am really excited about being here today to talk about revelation in data storytelling and data visualization. I think it's really appropriate that we are in a town that's focused on higher education, and it's a beautiful hotel. And in all of your rooms, there is a directory. There we go. There is a directory, and inside the directory there is this quirky little chart. And you'll see it's a lovely little pie chart, and one very small section of the quirky little pie chart says things real information that I actually learned in college. And that's appropriate for us today because for me, revelation is always based on something that you learned before. It's always based on prior knowledge. And so every piece of information that we learn is built on something that we necessarily learned earlier. And that works for individual graphics, and it certainly works on the shared knowledge within a community as well, like the community here at Tapestry. And here is a relatively quick example of what I'm talking about. This is a satellite image of North Dakota, a state that I was lucky enough to live in for a few years. And this is part of western North Dakota. And what you see here is all of the oil wells that have been built there since 2006. They're marked in yellow, so we've actually highlighted each individual one. So that's your surface footprint of that area of North Dakota. But underneath that is a whole fracking infrastructure. So those are all of the fracking pipes that are built underneath the earth. So we've made something that was invisible, or at least not visible to the surface. We've made that visible. But I want to build on what came before. So now you understand that there's this extensive network of oil wells in North Dakota and a really extensive hidden underground network underneath it. But I want to be able to put that in perspective. So my colleague, Gregor Aish, at the New York Times, decided to do something a little bit fun with that. So this is what North Dakota would look like if those drilling lines were above ground, and you've got the World Trade Center 1 up there for scale. So you can see how enormous these things are. So that's a clean example of what I mean to build to reveal. And revelation also really involves some discovery. As a reporter, I feel like I'm lucky enough to be able to make discoveries every single day in my reporting. You know, journalism is pretty fascinating in that way. And when I think about data storytelling, one of the things that I think is really important is letting my audience, letting my reader, letting my user be able to feel some of that discovery. This is a motion graphic that we worked on that looks at the Bangladesh coastline. The Bangladesh coastline is very vulnerable to sea level rise. So this is a model of what the coastline would look like if sea level rise rose by 13 feet. It's not just the water coming in from the ocean. The whole water table is changing. And all of the hundreds of thousands of people who live there, their land is being eroded. So they're moving. They're moving across the Bay of Bengal, and they're moving to a very large city called Chittagong. But Chittagong is not invulnerable. And about 18 million people are going to be displaced in the next 40 years. Part of revelation and part of building to reveal, I think, is testing hypothesis. And you don't have to have scientific data necessarily to test a hypothesis. One example that I worked on last year, a reporter named Jody Cantor was looking at the Harvard Business School and looking at the gender imbalance within the Harvard Business School. And so I decided to look and see what kind of data investigation we could do with the faculty at the Harvard Business School. So this is the tenured faculty, the male tenured faculty of the Harvard Business School. And it's a histogram based on the years that they've been teaching at the Harvard Business School. So the dot that's above the number 6, that's a single professor who earned tenure after just 6 years. And the dot above, I believe it's 52, is the tenured professor who has been teaching at the Harvard Business School for 52 years. That's your male tenured faculty. And this is your female your female tenured faculty, significantly smaller. The deans acknowledge that there is a real gender imbalance at the Harvard Business School, but they also tell us that the reason that there's that imbalance is because there's such a big lag in the time period that it takes to earn tenure. Probably there are a fair amount of people who are in academia here, and you know that the tenure process can be pretty long. At the Harvard Business School, it's about a decade. So the dean said, in about a decade, things should be really, really equal. It's all because of the time lag. And I thought, well, that sounds like a testable hypothesis to me, right? Let's take a look at the tenure pipeline then. So I took a look at the tenure pipeline. So this is all the male professors who are teaching but not yet tenured. And they're obviously weighted toward, they've only been teaching 2, 3, 4, 5 years. So there's quite a supply of them. So if the hypothesis proffered by the faculty that, in fact, in 10 years, the faculty will be more or less equal, you would expect, I think, that the tenure pipeline would have about the same amount of women untenured faculty. But it doesn't. So sometimes disproving a hypothesis can be just as important, obviously, as proving it. Layering information is incredibly critical. So the story that I just told you there about the Harvard Business School, I layered information on so that you could actually build to the point where I got a couple of laughs. And in that way, layering information is a tool that you can use to bring your audience to sometimes a fairly complex story, but you work with them kind of step by step. So one of the things that we spent quite a while looking at this year was Ebola coverage. And one of my colleagues, Albert Sun, looked at the model that the World Health Organization had put out that looked at how the number of cases was very dependent on the international response to actually getting involved in the West African countries. So in this is a model, and the black line is the actual number of reported cases that we had. And the colors, the light color is the high range, and the dark color is the low range that the model kicks out. And you can scrub back and forth and look at what would happen if the international community had responded a few months earlier or a few months later. So if the international community had responded not in August, and it was August and September that things really started to improve there, but what if the international community had in fact responded 2 months earlier? The number of cases would have been significantly lower. You can see how the model brings us to that. What if the international community had not responded in August and September and in fact responded 2 months later than it actually did, in October? The model tells us that would have been the outcome. Showing texture in the data is also incredibly important. I really drill simplicity because I think simplicity and clarity are some of the best tools that we have. But that doesn't mean that we don't want texture in our data, that we don't want richness, because I think that's where a lot of the beauty in what we do is. But man, it can be hard. It can be really hard to get that texture in the data without losing readers. So this is a piece that looks at air pollution in Delhi compared to air pollution in Beijing. Now, Beijing for a long time has been considered really one of the absolute worst cities for air pollution, and it's really bad. But if you look at this chart, you can see that in the wintertime, Delhi is actually significantly worse, and it has a lot to do with burning of garbage and the really cold winters in Delhi. But to get to this point, my colleague Gregor, again, who I work with a lot, we had gotten hourly data for 2 full years. Like, that's an incredible data set. It was really fun to play with. But ultimately, we wanted a very clean, very easy to understand chart. So we took a 4-week moving average that really clarified how much worse Delhi is in the wintertime than in Beijing. It was very easy for everybody to get. But I missed the texture of the data. And in using an average, as most of you know, you really tend to eliminate some of those highs and lows that can be really interesting. And I really wanted to be able to show my readers how much of a public health nightmare this really can be. So we started to look at different possibilities. And Gregor was working in R, and so we were playing around with a lot of different ideas. So the 2 main lines there are the moving average that we were trying to work out. But what we wanted to do to put behind it was something that allowed our readers to be able to see where those peaks were. Like, how high in a particular week did those pollution levels really go? And Gregor thought this might work, but I was having a little bit of trouble reading it, so I thought, hey, maybe we should try an area chart behind it that kind of shows peaks and valleys. And we thought that was a little bit closer, but it wasn't quite there because it got the busyness of the peaks and valleys, I felt like was much more of a distraction than it was really helping. So then we looked at bar charts, kind of compressed together, so I often call this a step chart. And that was getting us a lot closer. And so we fiddled around with that a little bit, and we ended up doing this, which I felt like has the overarching trend that I showed you before, but behind it, a little bit more subtly, you get both the Delhi and the Beijing readings, and you get a typical range. So we tossed out the highest 10% and the lowest 10%, and I'm just showing you that mid-range 80%. I thought the outliers were a little bit distracting, but this is a way that I can show you in the wintertime. In fact, a lot of these weeks are more than twice what the average actually is. So after you've had the fun of doing all the analysis, like we did with that hourly data, designing to reveal is incredibly important. I get to work with a lot of really interesting researchers and a lot of really interesting scientists, and I love to do that. And I love to see the kind of graphs that they create. And this is one that a scientist created, and it is on the relationship in India between sanitation and malnutrition in children, a very important topic. And he loved this chart, and this is the published chart that was in a very important paper, and he loved it so much that he put it on a T-shirt, and it's on his business cards. And I looked at that, and I thought, it's a beautiful chart. But to me, it's not revealing something that I want my readers to get to. And so what I wanted to do is to take data that was similar to it, but he had put it on a log scale in order to stretch out the data so that you could actually see those circles. And what I realized after playing with the data a little bit, that in fact, I thought sort of a more impactful visualization was to not use a log scale, and in fact, use the dots all compressed together. So this, on the horizontal, we have the number of people who defecate outdoors, normalized by area. And on the vertical, we have the percentage of children under 5 who are malnourished, who are stunted, who are very, very small, that are not growing properly. You have Afghanistan, way up at the top. They have a lot of children who are malnourished. But they do not have a sanitation issue. Haiti still has a sanitation issue. But what you see is a lot of these countries are kind of all together. And what this allows you to do is to see that something totally different is happening in India, totally different than any other country right now. That the number of people who do not have access to latrines and who defecate outdoors is so much higher compared to so many of the other countries, more than twice any other country. And that, according to the researcher of a lot of the scientists, that is the single reason why so many children are malnourished in India. It's not access to food like in a lot of other countries. It's sanitation. And that's something that governments can do something about. choosing form carefully. I think other people today are going to talk a little bit about matching the right form to the data and a lot of the different options that we have as data visualizers. But this is the point in the presentation when I have a little bit of a confession to make. Because when I get a new and interesting data set, I don't know about you guys, but one of the first things that I do is generally put it into the form of the thing that I just built. So I got this new data set that had nothing to do with India or sanitation. It actually had to do with the cost of echocardiograms. But it was 2 metrics, and I thought, why not put it on a scatter plot? It worked for India, right? Give it a shot, right? But like Ellie said, you have to be willing to make mistakes. But I thought, well, we'll put it together. So this is echocardiogram charges. And the horizontal is how much the bill for the echocardiogram was. Each dot is a hospital in the United States that does echocardiogram procedures. But the vertical is what Medicare pays, so what the government actually thinks that echocardiogram is worth. So you've got, on the horizontal, 0 to 12,000, and on the vertical, you've got 0 to 600. So right away, I knew that that bothered me a little bit because I have both money values, but the scales are radically different. And it's all clumped together, and I'm not really pulling out anything that, to me, right now is particularly revealing. So the first thing I do is I put it on the same scale, because that seems like a reasonable next step. And when I do that, then everything ka-chunk falls down to the bottom. And you get an idea that a lot of the Medicare payments are pretty much the same. But the bills for the from the different hospitals vary widely. The smallest one is about $400. And then for exactly the same procedure, it's about $12,000. Well, that seems interesting. I don't know if it's particularly revealing in that form. But it's interesting. So now I have my nugget of information, and I think, OK, what do I do next? And instead, I decided to go with a much, much simpler form. So these are bar charts. This time, instead of one dot being a hospital, each little tiny, very skinny bar that you can almost not really see is a hospital. But what you get right away is that the dark blue on the bottom is what Medicare pays. And then the light blue is the gradient that moves from the least expensive all the way up to that $12,000 echocardiogram. And it went with a story about one particular man who had had 2 echocardiograms in 2 different hospitals very close to one another. And one was very inexpensive and one was very expensive. And so it happened that I could point out to those 2 hospitals and see where they fell along the line. And Edward Tufte thought it was kind of fun. It's always nice to get immediate positive feedback. I know a lot of people in this room have gotten A+s from Edward Tufte. And I appreciate his willingness to jump into the Twitter fray with a lot of positive encouragement. So quiet clarity, I think, with revelation is one of the most powerful tools that we really have. So stripping out information that's not necessary and leaving you with sort of a single, very powerful message. Another project having to do with medicine that I worked on last year, actually it was 2 years ago, was looking at the mortality rate of breast cancer. And the mortality rate of breast cancer across the United States has been falling pretty significantly. But if you break that down by race, you see something that is really, really distinctive. So for both white women and for black women, the mortality rate has been falling. But there is a very large gap between the mortality rate in black women versus white women. And that wasn't always the case. This data goes back to 1975. And you can see in 1975, the mortality rate for breast cancer in women was higher in white women than for black women. But that changed in the early 1980s. You can see where those lines cross. The black women rate is blue, and the orange is the white women rate. So this is a little promo that is embedded in a long article on breast cancer. But what I really wanted to do with this data is to be able to look at it regionally, because across the United States, there are so many regional differences. So if you click on the Explore the Interactive Graphic, you get something that looks like this. And it has, for every state that we had data for, it has those two lines. But in my design, what I really wanted to focus on, what I thought was the most powerful thing here, was not, again, those lines themselves or the trend of those lines. It was the yawning gap between those lines. So what we decided to do with this interactive is to actually have it autoplay through the years. So as soon as you went to that page, the dots started moving. And then that gap started filling all the way up. So that's the gap through 1995. And then when you get to the end of the page, that gap is entirely full. And you can see all of that blue area, to me, is enormously powerful. And it has a lot to do with how our healthcare system is set up. Beware of the false reveal. I just want to take a little nod to the false reveal. I think most people in this room are probably aware that it can be a dangerous thing. And I will pick on BBC very quickly, because as you can see from this chart, they have their unemployment rate starting at 7.8 and going down to 6.5. And I bet just about everybody in this room can figure out right away that maybe they were a little bit overexcited in their visualization. But fortunately, we have the Twitter police. So thank you, Andy Kirk. Always edit wisely. The BBC can learn to edit wisely. Because mobile really requires it. Most of you have phones, if not in your hand, but sitting next to you. And those screens are tiny. Those screens are so much smaller than our desktop screens, and we have really had to rethink a lot of the ways we've been storytelling, really. More than half of the New York Times traffic now comes from phones. And so I know that then more than half of the people who see what I create are seeing it on a pretty small screen. So that caused me to sort of rethink story form and storytelling and start to experiment a little bit with new ways that we could actually use the phone and the functionality of the phone to be able to tell stories that were structured in a different way than you would necessarily put them together if you were going to put together something that was going to be in desktop or in print. So one of the first projects that I did with this looked at universal motorcycle helmet laws in states. So there were about 6 or 7 states across the country that in the past couple of years have been looking at legislation to repeal universal helmet laws. So that means that the law in the books for a lot of states right now is if you're on a motorcycle, you have to wear a helmet. It's simple. But a lot of the new laws being proposed had some age restrictions or age requirements, or you only had to wear a helmet if you were under 21 or under 18, rather than being universal. So again, I'm going to start layering. I'm going to start with a chart that shows that fewer people are dying in vehicle accidents. That line is pretty dramatic. Deaths from vehicle accidents were really flat for quite a while, and then they had a real decline. Cars are getting safer. Maybe we're getting to be better drivers. But in contrast to that, motorcycle fatalities have actually been rising significantly. So proportionally, more people have been dying on motorcycles than in the past. And I thought that was pretty interesting, and I wondered if there was any correlation to that and some of these laws that have been repealed. So I wanted to look at a very specific state. So I took a look at Florida. Florida was a great case, not only because I hear that it's a wonderful place to ride a motorcycle, but also because they repealed their universal helmet law in 2001. So we had a great before and after case, right? So you can see right there where that white line and that dot is, that's the moment where the helmet law changed. So you can see that there was a huge rise up there. So if you look even a little bit more closely, and you look at how many people were wearing helmets versus not wearing helmets in that, then you can really reveal the effect of the law. So the number of deaths really increased, and most of those people were not, in fact, wearing helmets. Now, a lot of the laws that were proposed, these repeal helmet laws, had in different states had made it either to committees or had made it to state legislatures, and a lot of that legislation had been tabled because people wanted to have more information about what happens when you repeal helmet laws. And so this could potentially add to the body of the research that legislatures can actually look at when they think about whether or not they want to repeal their own particular helmet law. The other thing that we do, because the New York Times is obviously a newspaper, is that we do it live. We do it fast, and we have to get our graphics up quickly. We have to get our reporting done quickly. And one of the most exciting places to be during an election night is a newsroom. And this year, this November, it was even more exciting because my colleagues, Amanda Cox and Nate Cohen, put together a live Senate model that looked at who is really winning the Senate so far. So we've all always watched election returns, right? We're glued to the TV, we're glued to our phones, we're glued to our multiple screens, and we're watching election returns. But what Amanda and Nate decided to do this year is to go back into some of the historical data and look at the reporting times of different areas in some states where the races were going to be close. And they built a model that could look at and predict what the actual returns, election returns would be versus what you were seeing in the reported data so far. So I'll show you how it works. In Virginia, where I happened to win, we thought it was going to be a pretty close race. So if you look at the map with only a few dots on it, you can see that's where the votes have already been counted. This is time-stamped at 7:27 in the evening. And the map that has a lot of circles on it, those are the places where the votes have not yet been counted. So it's very early in the evening. A lot of the precincts have not reported yet. But the ones that have reported are primarily Republican. So the reported lead right now at about 7:30 p.m., the Republicans are up by almost 19 points. Like, that is a heck of a lead. That is pretty exciting, right? But the folks at the Upshot have adjusted that number for when the different precincts actually report their votes. And they've adjusted it, and they say that the actual lead is actually 0.3 points. So it's early in the evening. We don't really know what's going to happen. So we take a look. Half an hour later. Half an hour later, there's actually quite a bit going on. So a lot more votes have been counted, right? Instead of an 18-point lead for the actual reported votes, the reported lead is now 9.3. But the Upshot model, looking at all the blue areas still left to count, they've already crossed the line. And the Upshot is now saying that it's going to be a Democratic win. Again, this is just shy of 8 p.m. It's pretty brave. So an hour later, a lot more votes have been counted. But according to the actual reported numbers, the Republican candidate is still up by 5 points. But the Upshot adjusted number is at 1.2. Twitter went crazy. And at 10 p.m., it's getting really exciting. Those lines are so close to each other. They are neck and neck, but they're still on either side of the win line, right? The reported number is Republican, less than a point. The upshot adjusted number is 1, but it's in the blue. And half an hour later, it's still, half an hour later, it is still enormously close, and here we go. Sorry, at 10:30 p.m., the reported number actually ticks over into the blue, and it ticks over into 0.1 points for the reported lead, and the upshot still has it at 0.4. So there's not very many precincts still left to report, and at 2 a.m., it's a clear Democratic win. It was a pretty exciting evening. And I admit that at the New York Times Graphics, we do like to have a little bit of fun, and that was a really playful evening to watch that unfold. And I think a little levity is really important in what we do. I think it can help to reveal, I think it can help to teach, and it can help us to build our community together. One of the biggest projects that I worked on last year was on the cost of healthcare. And I showed you one earlier that looked at the cost of echocardiograms. And that was definitely a much straighter shot. But there was another project that looked at the cost of prescription drugs and about how really enormously high they are in the United States compared to all the other countries. Same drug, same dosage in a lot of countries is just significantly less expensive. And the reporter, Libby Rosenthal, looked very closely at a lot of the asthma drugs that fall into this case. And I started looking around at the data. And the data looks a lot like this. So I had, you know, probably 45 spreadsheets that looked like this, that were lists of countries and lists of costs and lists of drugs. And I thought, there's got to be a way that we can show how over the top this expense is, how absurd, really, that the difference in pricing truly is. So we decided to do something a little bit different. One inhaler in the US costs $250, and you can get 7 in France. That's another kind of inhaler. So with that, I want to move to how important it is to really engage the power of the community. This is an amazing community in Tapestry. It's beginning to feel a little bit like family. And I feel like we look at each other's work, whether we're from journalism or academia or research or industry. We see each other's work, and we have a real shared body of knowledge. And I think that that is such an incredibly powerful thing. And the last example that I want to show you is how that can all work together, and about how we can really pull together as a community to build some pretty incredible things. This is a tree map one of the very early tree maps from the 1990s that came out of Ben Schneiderman's group at the University of Maryland. And they call it the Pro Basketball Analyzer, so you'll recognize a lot of the names of the teams. You may even recognize some of the names of the players. And this was something that a new form that that group played with and invented and shared with the community. When I was a relatively new hire at the Times, Ben Schneiderman came to the New York Times to share his research, to show this to us, and to say, look at this neat stuff. I wonder what the world can do with it. I wonder what you can do with it. And I thought about that, and it took me a little while to kind of think about what the right data was going to be able to use a form like this. But a couple of years later, Amanda Cox and I put together the New York Times first tree map. And it was for the business section. And it actually looked at car sales. So on one side, you have all the American car sales, and on the other side, you have non-American car sales. And one of the things that I really wanted to highlight here was the shift that non-American car companies were making to selling smaller automobiles as opposed to trucks or big SUVs. This was published in 2006, and there was beginning to be a real turn. But a lot of the American car companies were still churning out SUVs and expecting people to buy them when, in fact, demand was changing a little bit. And I thought that was a really interesting example. This was not interactive, even in 2006. This was flat, and it had a lot going on, but it was a way to experiment with this new form that academia had introduced to the world of data visualization, and I was pretty excited about it. And we still use them. All of you may be familiar with budget graphics. This one was from 2012. It's a really great way to get a quick sense of understanding the United States budget. And I was incredibly impressed that Ellie showed a tree map, which brings me full circle, a tree map of this wonderful community, of where we come from and what we end up doing with this data together. Thank you.
Any questions? So raise your hand and I'll come around with a mic so that people on the live stream can hear. And then can you let this mic go?
Hi, thank you for your presentation. My name is Dave Edwards from ACT. And I was curious when you talked about the helmet law, and you don't have to answer a specific question, but when you are looking to write your story, do you sometimes try to decide, hey, I have a motive, I want to create a reaction in my audience, and so therefore I have certain information that I'm planning to sort of say this is what's important. How do you be careful about not making sure that you're not failing to include important information, like how many people are riding their motorcycles? Because that's one of the big things about helmet laws is people just don't ride because they don't want to wear a helmet, and so they have to. And so more people are riding.
Sure.
So how do you balance what you're telling and what your motives are?
Usually when I start a reporting process, something like that, I don't have a motive. So what I had was some really interesting auto fatality data that I had worked with for a couple of other projects, I think one of which I showed 2 years ago at Tapestry, looking at a connected scatter plot and looking at fatalities and basically auto safety. So I had this really interesting data. And so I started to query it, and I decided to look at motorcycles because I was very interested in auto fatalities going down, but motorcycles going up. So that was kind of my entry point into it. And then as soon as I got in there and started exploring and realizing that so in my reporting I realized that that legislation had been changing in a couple of different states, and there were actually a few different states. I didn't show you the whole interactive. Florida was one of them, but there were a few different states that you could actually see a kind of before and after. And I thought that that was a really interesting test case for the legislation. And I think that when you start with a story like that, you have a question to ask, and then you get in with a hypothesis. like as I explained before. And in this hypothesis, or really a question, what happens? And what clearly happens is that a lot of people, more people ride motorcycles because it's an incentive, and a lot more people end up dying. You certainly could have normalized for population in those particular charts. What interested me in those charts was the sheer number of people dying. So I wanted to see each individual who died, and so that's why I used a count rather than normalizing for population.
Thanks.
Sure.
Hi, Hannah. Thank you. Mike Pell from Microsoft. I love the piece on prescription medication cost. And as a designer, of course, I love the animation. You could have used different forms to get the same information across, but you chose something that I think sort of borders on persuasion, perhaps, or a little bit of opinion. When is it appropriate to use those forms in your work versus just straight up representation?
Well, it was certainly playful. And I decided that the story, that the data itself was economic data. And when you compare prices of things, it's sort of necessarily economic data. And I look for ways to make economic data as interesting as possible. I worked on our business desk for many, many years. And I find economics and business data to be very, very interesting. But I do admit that I look for more creative ways to play with it. Health data or other things that have to do with crises or death, I tend to not go a playful route. But for something like this, I thought the volume comparisons, that there was an interesting opportunity there. We could have used bar charts. That certainly, early in the process, would have been a perfectly logical thing to do. A lot of the different projects that we did for this particular series, which was called Paying Till It Hurts, it had about 11 or 12 pieces to it. A lot of them were played very straight. But I decided to go a little bit fun with this one. I saw an opportunity, and I thought that there was just a little bit of amusing shock value that I thought that we could do with that. It got a really interesting response. I think some people thought it was one step beyond what might have been appropriate for the story. And I think a lot of people remember that when they leave a talk like this, or when they leave the story, they remember the falling inhalers. And that's impactful too.
Yeah. Very effective. Well done.
Thank you. Other questions?
Hi, I'm Trina from InfoActive, and I was really interested in the pollution visualization that you created and the iterative process for that. And I'm wondering how many people were involved in that feedback cycle or feedback loop, and if there comes a point in time with your visualizations where you say, okay, we're getting all of this really great feedback that's coming from all of these different perspectives, and they want us to try 12 different things, but we just got to get this out the door, even though we may agree with the feedback from X, Y, and Z person.
In that particular example, it was just the two of us. It was Gregor and I together working through the data, and we were actually, because he's in New York and I'm in DC, we were inside a Slack channel, and we were flipping images back and forth. It took about an hour to get to the point where we were both really happy that we could show those nice, clean averages, but also put the texture behind it. So it was just the two of us in that example. For another example that I showed you, the one where I used the scatter plot to show the echocardiograms, and then realized after I'd taken the graphic almost all the way through to sort of a publication level graphic that in fact it was kind of a total disaster, and I had to start back. What I ended up doing with that is looking at the one that was the scatter plot, and then I also did the bar chart one that I ended up publishing, and I put them side by side, and I said, I'm pretty sure it's the bar chart, but I'm not absolutely sure. And so I took 2 screenshots, and I sent it to my editor, Matt Erickson. And I said, is it just me, or is one of these really a lot better than the other one? And he looked at that, and he was like, I don't know what you're doing with the scatter plots, but you better go with the bars, because it was very, very clean. So we have a wonderful editing layer, but it's pretty quick, because we're a newspaper, we're getting things out really fast. So sometimes when we do things jointly, it's just Gregor and I doing it together, and then an editor will look at that and make sure it's fine. Or in some cases, if I feel like I need more feedback, then I'll work with another editor, and we'll talk about shaping it. Other bigger projects sometimes have a much much more extensive editing layer. Those two that I showed you were actually pretty quick pieces.
Maybe we have time for one more question. We'll do two.
Hi, Hannah. So my question is about the graphic you showed that was the simulation of Ebola situations. And I'm curious if you have any guidelines for communicating simulations or predictions or tips and tricks about how to be honest with your audience about data that you're synthesizing from a model which itself has parameters and has been set up a certain way. Can you speak to that a little bit?
I think it's a great question because it's a very important, powerful tool that we're using more and more. So in my presentation, I had two simulation examples, one of which was the election data and one of which was Ebola. And I think you're going to be seeing a lot more things like that. And I think that the best thing that we can do in those cases is to show what we know and what we don't know. So in a way, the data that's going into the model and the model output. So in the Ebola example, I had a heavy black line that was the actual reported cases. That never changed. But as you could flick through the model and scroll through it and change whether or not you wanted to see what would happen to the model if international intervention was 4 months earlier, it's the colored areas that change. The reported cases never changed, but the model output actually changed. And you'll notice in that example too, it had several hundred words of text up top explaining it, and it was pretty heavily labeled to say this is a model. In the election piece, you had always two lines, the modeled line and the actual reported line, and you watch them kind of come together. But to me, again, having both of them, what you know is the actual reported data and then the model overlay, being able, at least right now, to have them both together helps your reader to understand what we're doing with the model, that we are, in fact, creating something, we're putting inputs into it and getting outputs. I think it's for a lot of readers, it's a very new thing. And so the best thing that we can do right now is to heavily label and to really shape a framework around it and to be able to show what we know and then what we don't know.
Hi, my name is Sue Fleming, and I'm with a World Bank partnership. You spoke a little bit about mobile and stuff being mobile responsive. Could you go a little bit further on that? I mean, if half of your readers are coming in through mobile phones and smartphones are becoming much more important globally, so your global audience, I would assume, is going to grow at the New York Times as more people come in. How do you think that is going to affect how people plan infographics and data viz, the whole bang shoot? What do you think the impact is going to be over, say, the next 2 or 3 years? Because the price of mobile is going down.
I would say that it's already really been a game changer in the past year or so. When I sit down to do a graphic nowadays, I think really hard about what it's going to look like on mobile first. So on my screen and on my sketch pads, I'm looking at not an area that looks like this, but I'm looking at an area that looks like this. And I am constraining it and editing it and writing it to that screen, usually first. And then I can see if I can back out of that and make a beautiful desktop presentation, and then oftentimes back out of that and make something that's beautiful for print. So we're still kind of 3-step iterative. But that motorcycle piece that I showed was, in fact, the first time that I ever thought about doing that. The first iteration of the motorcycle piece was a huge data visualization, interactive chart that had a lot of hovers where you could look state by state to see what was happening in each individual state. But it needed a platform that looked like this, and it needed tooltips. And so I worked on that for probably a week or 10 days. A lot of times these sort of bigger things, I work kind of in the background of my head, around the news, things like that. So I had invested a fair amount of time in that. And then I had sort of looked at it together, and I thought, and this was 18 months ago or so it was before we really had as many mobile readers as we do now, but I looked at that and I thought, this is not where the future is. This kind of visualization is something that needs to be rethought. And I know that I can tell the same story in a way that is going to work with the form that more people have. So I would say, you know, we're going to do more of that in the past year, but I almost feel like we've hit that moment already.
Thank you very much, Hannah.
Thank you all.